Hello class, welcome to this video on 6.1 review. All right, so let's go and get started. So we have several problem sets here. Problem set number one is being able to identify perpendicular bisector theorem, converse of the perpendicular bisector theorem, and just being able to apply it. All right, so let's go ahead and get started. So remember, if you look at perpendicular bisector theorem, it states that if you have a perpendicular bisector, meaning if these two are congruent, then that means these two are congruent. So it's a bisector and it's also perpendicular right there, okay? So hence the term perpendicular bisector theorem. This one is the converse, it's the reverse of that. So it states that if these are congruent, then these two are congruent, and then this is a bisector, so this is perpendicular, okay? And so therefore this is 5. All right, so you just have to identify which theorem and the answer. Really simple. So here we have that this is a perpendicular bisector because we got a right angle and we got two congruent sides. It cuts it in half. So if those are congruent, then these are congruent. And that's the perpendicular bisector theorem, okay? So perpendicular bisector theorem. All right. You could say PBT for short if you want, but there it is, perpendicular bisector theorem. So I'm going to put PBT for perpendicular bisector theorem, and then I'll put CPBT for the converse. All right, this is not this is just something for us to kind of shorten it for the lesson, for the practice. So therefore, this is 2.8. I can go ahead and do that. This one, now these two are congruent. This is a perpendicular bisector, so therefore these two are congruent. Really straightforward. And that is the perpendicular bisector theorem. All right, and then the next one, these are congruent, so therefore these are congruent. That is the converse of the perpendicular bisector theorem. So CPBT, I'll put for short. And if the whole thing is 12, then each of these have to be 6 apiece. So KL is 6. All right, and this one, these are congruent, so therefore these are expected to be congruent, and it's a right angle there, so it's expected by the converse of the perpendicular bisector theorem, so therefore BF must be 4.2. All right, it's really straightforward. So the next problem set is also using the perpendicular bisector theorem, so if these are congruent and we got a right angle, then these are congruent. So then we set them equal to each other, and then we subtract 3x on both sides. So we solve it, and then we get 2x equals 14. Divide by 2 to get 7, and then we plug that into CD. Remember, this is CD right here. So 3 times 7 plus 14 to get 35. Okay. All right. So let's look at the first one. So again, perpendicular bisector theorem. If these are congruent, then these are congruent. So this is actually this one right here is the converse of the perpendicular bisector theorem, whereas this one right here is the perpendicular bisector theorem. So there's a difference. This is perpendicular bisector theorem. This is the converse of the perpendicular bisector theorem. All right, so we go ahead and set those equal, and we'll solve here. So we're going to subtract 3x on both sides. Then we'll go ahead and add 6 to both sides. All right, so we got 2x equals 14 divided by 2. So we get x equals 7. All right, and don't forget, we're going to plug it in. So we're going to plug this into here. And if we do that, we got 3 times 7 plus 8, that's 29. So we get 29 here, and remember these are the same on both sides, so this is also 29. And remember, we are trying to get CA, which means we need to combine those two numbers, right? So 29 plus 29 is 58. So our final answer is 58. All right, so let's do TU. Again, if these are congruent, then these are congruent. That's the converse of the perpendicular bisector theorem. So then we set them equal. And then we solve, okay? So I'm going to subtract here. I'm going to subtract 2x on both sides, and then I'm going to add this 30 over to the other side. So we get 54 equals 3x. I can divide by 3 on both sides. So we get x equals 18. And don't forget to plug that in, the TU. You want to look for TU, right? So we got to plug this in here. So this is 2 times 18 plus 24, which is going to be 60. All right. Number 3, again, so this one, if these are congruent and then this is a right angle, then these are congruent. That is the perpendicular bisector theorem. Okay, so you need to know the difference between the PBT and the CPBT, just in case, right, when you're looking at a proof or something like that, or explanation. So, but either way, the result is the same. We set the equation equal and we solve, right? So we subtract 3x on both sides, then we add the 16 here. So we get 24 equals 4x. Divide by 4. We get 6 is equal to x, right? And then we got to make sure you plug it in. So we're going to plug this into AB. So we get 3 times 2, or 3 times 6, because x is 6, plus 8 is 26. All right, and then same thing here. So now this, if these are congruent and then this is a right angle, right, then these have to be congruent. So that's the perpendicular bisector theorem. All right, so we got 6x plus 11 equals 11x minus 9. And then we're going to subtract 6x on both sides. Then we're going to add 9. So we get 20 equals 5x. I'm going to divide by 5. And I get x equals 4. And then I got to plug this in. So I'm going to plug this into AB, right? Remember, this is AB right here. So we get 11 times 4 minus 9. So that's 44 minus 9. It should be 35. All right, so that should take care of that one. So that's the first, that's the second problem set. So problem set number 3 refers to circumcenters. So we take 3 perpendicular bisectors and they cross at something called a circumcenter. Okay, so a circumcenter, it says point G is a circumcenter, and therefore we have perpendicular bisectors. So that means that these lines that you see here, these dashed lines, are perpendicular bisectors that cross the sides of the triangle at a right angle, and it bisects the sides, right? So they're the same on both sides. So these are both 20. These are both 15. This is another right angle here, although it's kind of hard to tell because it's so tiny. But there's a right angle there. I'm going to try to draw it best I can. But there's a right angle there and a right angle there. I might as well not even draw the right angle, but I'm going to try anyways. Right there. And then this is congruent to this. Okay, so these are both 24. And then it also means, the circumcenter also means that these distances, the distance from the circumcenter to the vertices here, are the same. So these are all the same right here. So basically, if this is 25, then this is 25, and then this side right here is also 25. Okay. Okay. So now that we got that information, what we do is just we focus on this side, that triangle, and that's the triangle that you see drawn here. And remember that we can solve for this. This is a right angle here because it's a perpendicular bisector. So because it's a right triangle, we can always use Pythagorean theorem. Remember, Pythagorean theorem is a squared plus b squared equals c squared, where you got a, b, and c, where c is the longest side. Okay. Okay, so in this case, this is the longest side, so we got a squared plus b squared equals c squared. So we got a squared plus b squared equals c squared, okay? So this will be like my a, b, c. Okay, so we got dg squared plus 20 squared equals 25 squared. 20 times 20 is 400, and then subtract 400 on both sides to get 225. And then remember, we got to take the square root of both sides, right? And that's what we do in this next step to get 15. All right, so hopefully that made sense. So, and then that's the idea. So if we do number 1, this is a circumcenter. And so remember, if that's a circumcenter, these distances are all the same. And that also means that the circumcenter is formed by perpendicular bisectors. So I'm going to put right angles here, 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 here. And then these are cut in half. So I'm going to do that. All right. So now what we want to do is essentially, well, okay, so if this is 11.1 here, right, then this is 11.1 right here, and so is this one. Okay. And so we want to focus on this triangle right there. Okay. So if I focus on that triangle, we have a triangle that looks like this, and I'll keep it in red. So we got 11.1 here, we got 5.2 here, and we got this. So again, using the Pythagorean theorem, we got a squared plus b squared equals c squared, right? So we got br squared plus 5.2 squared equals 11.1 squared. All right, and that's what we're looking for is br. So what we're going to do is I'm going to basically I'm going to subtract both sides by 5.2 squared. So I get br squared equals 11.1 squared minus 5.2 squared. And that's going to give me a number. And remember, the only way to get rid of this square is by doing the square root, right? So I'm going to take the square root, and that's going to get rid of the squared. So we got br equals the square root 11.1 squared minus 5.2 squared. And then we do this math on the calculator, right? So, and I'll show you if you just did this. I'll just do it here. Square root 11.1 squared minus 5.2 squared, and you get 9.8, so 9.8ish, right? So, okay, and there's the final answer. All right, so number 2, H is the circumcenter of the triangle. Same idea. Okay, so remember, if this is a circumcenter, these are congruent, and then these are cut in half, so those are the same. Those are right angles. These are cut in half. These are cut in half. These are right angles. So because this is 5.06, that means this is 5.06, and then this is 5.06, right? And we're trying to look for FL, right? So since we're trying to look for FL, we can use this triangle to help us. Okay, so that FL triangle, I'm going to try to draw it better here. All right, so we know that this side is 5.06. We know this would be side H here, or point H. And then this is 2.74. And so we got the a squared plus b squared equals c squared. 5.06 is the biggest side. Okay, so we got FL squared plus 2.74 squared equals 5.06 squared. Then we're going to subtract 2.74 squared on both sides, right? You got FL squared equals 5.06 squared minus 2.74 squared, whatever that is, and then take the square root So FL equals square root of all of that stuff. And again, you can do it before you take the square root. You can figure out what this is. But I'm just writing this out so you can see the whole thing. And then we take the square root of that. We get 4.3. Okay. Hopefully that made sense. Now, when you get to number 3, actually number 4 is messed up, so you don't have to do that. Number 4 is actually a lesson 2 question. It's not a lesson 1 question. So P is not the circumcenter, so that's why that's incorrect. And then number 3, we had to adjust this question because this question is not quite right. This should say if PB is equal to, or no, so yeah, so this is what the question should say. So I'm gonna cross this out, okay? If AP equals 6, BC equals 8, find PQ. Okay, that's what the question should say. So in this case, AP is 6 and BC is 8. And then PQ is what we're looking for. Okay, so if this is truly the circumcenter, then these should be the same distance, right? And then these should be perpendicular bisectors. So here is cut in half. Here is cut in half again, and it doesn't look like it's cut in half in the picture. Is because I used a different example, so this is not quite right. But we're assuming that this is all cut in half nicely. Okay. But there you go. Assuming that that's the case, they're all cut in half, then we can proceed. So what we can do is, well, because these are cut in half, if that's 8, then these are both 4, right? So that's the main idea. And if this is 6, then this has to be 6, and this has to be 6. And then we can focus on this triangle right here. Remember that that's a right angle there. We can focus on this right triangle in order to solve for PQ. So we got here, we got that triangle, and this side being 6, this side being 4. So again, a squared plus b squared equals c squared, right? So we get PQ squared plus 4 squared equals 6 squared. Then we can subtract 4 squared on both sides and then take the square root. So I'm just going to go ahead and skip straight to that. Okay. And then just plug that in, and then you get that in as a decimal. Because right now we're not concerned with simplifying the radicals just yet. We'll do that in another time. But for here we got, let's see, let's actually calculate that just to make sure. Okay, so about 4.4. All right, so about 4.4. Actually about 4.5 because it's 4.47, right? Yeah, so I'm going to round that. All right, and again, can't cross out number 4 because that's not the correct type of problem that I wanted to introduce. Okay, so we're going to do the last problem set here. So it says here, Alonzo wants to install a fountain in his triangular garden. Where should Alonzo place the fountain so it is equidistant from the vertices of the garden? All right, remember what we just talked about here is that the circumcenter is the same distance from the edges of the triangle, right? So that's what we're going to employ here. So remember that for any triangle, the circumcenter is the same distance from all of the vertices, the corner points. Okay, so we got to find the circumcenter here. But how do we do that? Well, we do that by doing the perpendicular bisector. Right, we cut it in half, and then we figure out where they cross, and where they cross right here is the circumcenter. So that's what we got to do. So if you do that here, right, in this example, well, you can see that if I draw these two perpendicular bisectors, right, we have that's a perpendicular bisector because it cuts this in half, and that's a right angle. This is a perpendicular bisector. It cuts this in half, and that's a right angle. And if we were to do one more here, you would see that's a right angle, and it cuts this in half, right? But you can see that they cross just below the 4. There's the 2 and the 4 line there. So it crosses just around below 4. So the answer is around 3.8. Now, in order to get this with algebra, I'm going to show you how to do this one with algebra, okay? So we'll actually, I won't show you with this one. I'll show you with the actual examples. So let's do that just to save some time. So that way we could just do these, focus on these two examples. Okay, so a monument would be at the circumcenter. So we're going to do the circumcenter, and then we're going to use some algebra, okay? And because the algebra is going to be pretty heavy, I'm going to try to fit in as much algebra as I can on here. And we'll see what happens, okay? All right, so let's go ahead and get started. So pick 2 lines that you want to do bisectors for. Okay, so pick 2 of them. I'm gonna pick this line, or yeah. So I'm gonna do the one that is horizontal, right? Because that's the more obvious choice. I'm gonna do this one here, and I'm gonna do this one as well. So if I do this side, then we know that the midpoint is here. Right at that point there. So, and if you struggle with that, you could just do the midpoint, right? So the midpoint formula for these guys, just add them up, divide by 2. Okay, so 1 plus 7 divided by 2, and then 5 plus 5 divided by 2. And that's going to give you 4, 5, which is exactly that point, okay? So that point is 4, 5. And then let me just write that there. Okay, so notice that this line right here, and which in this line, if I do it straight down, it's going to be a right angle with this, right? So that's my perpendicular bisector, and it crosses at, this line is x equals 4. We know it's x equals 4 because it's just going straight up and down, and it's at a value of 4. Okay, so we're going to call that equation 1. Okay, so equation 1 is x equals 4. Now we're going to get equation 2. Equation 2 is a harder one. So for equation 2, first off, let's find the midpoint. Let's do the midpoint of this guy. All right, so let's do the midpoint here. Let's take these coordinates, add them up, divide by 2. So 1 plus 8 divided by 2, 5 plus 0 divided by 2. And so that gives us 9 divided by 2, and then 5 divided by 2. So that gives us 4.5, 4.5, and 2.5, 2.5. So this point has to be right here, which is at 4.5 and 2.5. So I'm going to go ahead and point. So this is going to be this point right there, okay? And then I can cut it at a right angle. And all right, I'm going to try to, let me draw this a little better here. Okay, so this is about right angle, a right angle there. We're just assuming. So actually, what I'm going to do is, okay, so here's the concept, okay? So here's where we start using some more algebra. Now, before I draw this out, we know if we're looking at this line right here, we know that we can find the slope of that line. So let's go ahead and find the slope of that line, all right? So the slope of that line, you have to go down 5, so that's -5, and over 1, 2, 3, 4, 5, 6, 7, and over 7, right? So the slope of that line right there, okay, is, let me do it over here. The slope is, which is m. Remember, m is the slope. is rise over run. Okay. Now, if we want the slope of the line that's the perpendicular bisector line, well, that slope is going to be, and I'll do it in red, is going to be positive 7 over 5. Okay. Okay. So we got the slope is, so the slope of this line, the slope of this line right here has to be 7/5, right? So or up 7 over 5. So let me just draw this out. So it's got to be up 7 over 5. And then let me just continue this here. So it looks like it crosses almost at 2, right? Almost. Not quite. I'm going to need to make this a little bit. It's going to be a little tough, but I'll try to draw this out the best I can. Okay. It's not a very good line, but you get the idea. But it's going to cross around around here, right? And then we're going to figure out exactly where it goes. So what's the equation of that line? Well, now that we know the slope, what we can do is we can do the equation of a line. Remember, the equation of a line is y equals mx plus b. But there's another equation of the line that you can use as well, and that's the one that we're going to use, okay? So let's go ahead and use that. So here is the equation, okay? Y minus y1 equals m times x minus x1, okay? So that equation says that, okay, if you just pick one point on that line and you plug it in to there, and then you know the slope of the line, right? Then you plug it into there, then you get your equation, okay? But this is the equation that we're going to use, okay? So y minus y1 equals m times x minus x1. So what's m in this case? Well, m is 7/5, all right? So we get y minus, and we're going to use these coordinates right here, okay? The coordinate for this point where it crosses right here, right? It crosses the midpoint, which was 4.5 and 2.5. And this is going to be our x1, y1, okay? So we got y minus y1 equals m. Now the m is the red slope, 7/5, times x minus x1. x1 is 4.5. All right, and there we go. There's the equation of the line. And now what we want to do is we want to take this value here and we want to plug it in, right? So I get y minus 2.5 equals 7/5 times, now we're going to do the 4, right? The 4 that we said there, minus 4.5. And this is going to help us figure out where it crosses, okay? So y minus 2.5 equals 7/5 times negative 0.5. 4 minus 4.5 is negative 0.5. And then we're going to add 2.5 to both sides. We're just doing the math here, so move the 2.5 over. Actually, let's figure out what 7/5 times negative 0.5 is. 7/5 times negative 0.5. So that's negative 0.7, okay. So let's just call this negative 0.7. So we get y equals negative 0.7, and then we're adding this to both sides, by the way. So plus 2.5. So then it looks like I get y equals 1.8. All right, so there you go. So it looks like it crosses at 1.8. That's pretty simple. That's pretty close to what we got here by estimating, right? 1.8. So the coordinates are, well, it's got to be x equals 4, and then y equals 1.8. And there you go. So that's where the circumcenter is for that particular triangle. Okay, that's how you use the algebra. There's the algebra that's involved there, okay? You know, so a decent amount of algebra. The designers of a new amusement park want to locate the restrooms the same distance from the entrance, fountain, and the food court. So we got these 3 things. So we're doing the circumcenter. Calculate the coordinates. All right, so we're going to use this line right here. The midpoint of that line is right here, which is, you know, it's 0, 3. Or yeah, 0, 3. Okay, and so we're going to draw this line, and that's going to be at a right angle, right? And so the equation, we're going to call that equation 1. I forgot to call this one equation 2, by the way. But anyways, equation 1 is x equals 0. Okay, because it's a vertical line, it's at the origin 0. Okay, and then the second equation. So now we're going to pick one of these lines. Let's just pick the one on the right. So if I pick the one on the right, where is the center here? The center looks to be around there. Again, let's use the midpoint formula to verify that. This coordinate right here is 6, 3. This coordinate right here is 0, 7. So just add these up, divide by 2, okay? So if I use those coordinates, 0 plus 6 divided by 2, 7 plus 3 divided by 2. And so that gives me 6 divided by 2, which is 3, and 10 divided by 2, which is 5. So that's 3, 5, which is that point that I got there, okay? All right. And that point is going to be important. So I'm going to put that point in red. All right, and then we get this to cross here. So if we were to do a right angle, so it'll be approximately there. It might cross at 0, 3. So it actually might cross at 0, 3. So if that's the case, well then that makes it easy, right? It's going to cross at 0, 3. However, we're still going to show you the algebra. All right, and then we're going to call this equation. Let me just draw this line all the way down. We're going to call this equation 2. Okay. Now let's get the slope of this line, this original line. Okay, I'm going to get the slope of that line, so I'm going to do rise or run. Okay, so it goes over 6. So it goes over 6 and under, so rise or run. Oh, actually, it goes down. It goes down from 7 to 3. So it goes down 4 and over 6. Okay. So then the slope of this line is rise or run. So negative 4 over 6, which is negative 2/3. Okay. And which means that the slope of the red line for equation 2, line number 2, it's got to be perpendicular to that. Okay, so it's got to be, you flip it and you switch the sign from negative to positive and vice versa. So it's got to be 2/3. All right, and then the point where it crosses, and then the point on that line is 3, 5. So I'm going to put that here, 3, 5. This is going to be x1, y1. All right, and remember the equation, y minus y1 equals m times x minus x1. So we got our x1 and our y1, and we got our m, okay, which is the 2/3. So I'm going to write that equation down. So we get y minus y1 is 5 equals m times x minus x1. All right, and then we're just going to do the math. So we're going to plug in 0 into here so that we can figure out where it crosses, okay? So, so we get y minus 5 equals 2/3 times negative 3. Now, 2 times these cancel because there's a 3 on top, 3 on bottom. These actually cancel. Actually, I'm not going to cancel them. You can cancel them, but let's just write it this way. So this is over an invisible 1. Multiply straight across. So 3 times negative 2 is negative 6. And then 3 times 1 is 3. And then we got y minus 5 equals negative 6 divided by 3 is negative 2. Right? And then we can just add 5 to both sides. Okay, y equals 3. So it actually does cross at 3. It crosses at x equals 0 and y equals 3. So 0, 3, there's my answer, done. Okay, so we actually were actually able to find the answer without doing algebra, just using this picture. Okay, But sometimes you get a decimal and then you have to figure out exactly where it is, okay? But that's going to do it for the lesson review, guys. Hope you found this useful and informative. As usual, I'll see you in the next one.